Welcome back to Switch to Linux. Well, today we're going to talk about the next version of Ubuntu. They just keep on putting a lot of little things in here, and a lot of things have been taken away from the news. Obviously, the big one is the new Snap Store with the controversies around that. We have the new GNOME implementation. But the one thing that we haven't heard a lot about is Ubuntu is now putting in optional TPM-based encryption. So this is utilizing the trusted platform module in your computer. You know, that thing that Windows 11 is trying to force on your system. And it's going to allow you to have much safer and better disk encryption because it's lower user input. In other words, hey, you can be lazier and still use this. And so it means that the risk of data loss might actually be higher. Now, I did look at some of the articles around this, and one of them I went into a warning about the disk encryption offered in Windows 11 because it is based on the TPM. And the problem is a lot of people, it's so low level that most people don't even know it's there to begin with. And the problem is that if your hard drive survives, but your computer board blows up, your TPM module goes bad, and you have not saved any backup keys to access the data, your data is lost, even if your hard drive is not compromised in any other way. So it is good in a way that if somebody steals your hard drive, they really can't brute force it as well. But it is still possible to brute force it. I mean, after all, there are very complicated export keys that you can use to back up your data effectively. It's just most people are reporting on support forums. They didn't even know they had to do that. And of course, with Ubuntu trying to say, hey, let's go ahead and implement this better, now they're saying, hey, it's a lower barrier. Now, there are reasons to use this. There are certainly positive applications. Now, also, this is something that has been tested in the Ubuntu core for a while, which is that immutable-based system they've been experimenting around with. And with this new version here, it is optional to enable it. And of course, it requires snaps. Very interesting indeed. So here's the article. This came out a couple weeks ago. I wanted to take some time to read up about it and think about the various pros and cons and implementations here. So the Ubuntu 23.10 release is going to introduce an initial TPM-based disk encryption to make use of the TPM module inside of your system. This will require you, of course, to run your secure boot, which I'm guessing Ubuntu has solved. I didn't know if they solved their issue with secure boot, but apparently they have, because the TPM module for disk encryption does require the secure boot platform to be functioning. So this is going to be based on a snap package, which means the grub bootloader, the kernel, and the encryption module all are run by Snap, and the Snap user agent is what is controlling your disk encryption. That might terrify some of you. That might comfort some of you. So I did look into it, and from what I can tell, the Snap agent is an open source component. However, it is still installed through their proprietary means. And so we're talking about high-level items being installed on your system dealing with full disk encryption in a proprietary manner, which I think is problematic in some ways. Now, this being said, if you want to use this full disk encryption, you'll have the ability to set it up. It's going to be an optional, and they have said so far that they're not removing the old simple LUX method of encryption. In fact, the new TPM-based is effectively a LUX version, but it's a LUX version where the keys, instead of prompting you on the screen, which they say is so horrible to have to input your password. Really? Really? Can we get off of this idea that it's such a horrible, complicated thing to import a password? We just have to rely on the hardware to do it for us. There's a lot of problems with that. You know, if someone steals your computer, they have the TPM module, they can kind of breach your system. A little easier, actually, if somebody gains the physical access. Now, over on Ubuntu's blog, we see more details. Again, this came out a few weeks ago. So full disk encryption is coming to Ubuntu. And they are talking about, for 15 years, their approach has been based on passphrases and authenticating users. The core, however, the encryption has been designed and implemented with the TPM. And they've been doing this for about 2 years now. So this is the first time they're moving it onto the desktop. So based on the Core's FDE design, we've been working on bringing a TPM-backed full disk encryption to classic Ubuntu desktop systems starting with 2310, where it will be available as an experimental feature. Passwords will no longer be needed on supported platforms, and that the secret used to decrypt it will be protected by the TPM and recovered automatically only by early boot software that is authorized to access the data. Besides its usability, it also protects its users from evil maid attacks that can take advantage of a lack of way to authenticate the boot software. So that part there is certainly something to think about. The ability of Linux to boot and load your system the way you want sits in opposition to attacks like this where you want to authenticate every single portion. Some people, it might be important to have something like, Linux installed on this portable hard drive that I can plug into literally every computer and it'll boot. But if you're utilizing a module like this, your operating system is now tied directly to that one computer. A change in the board, a change in the TPM module is going to make that disk non-bootable with everything else. So you're going to sacrifice your portability for your security. Whereas the way I'm doing these external drives, you can still encrypt with LUKS and go through the horrible torture of entering a complicated password every time you boot the system. Please, can we stop making a big deal about entering passwords? Because it is the way. When people start adopting this passwordless entry, they will have effectively broken into all of our systems, given our systems control to somebody else. Passwords are still the way you want to go. Or passphrases, whatever you want to use it. So this article here does cover the methodologies for how disk encryption is used. We'll go through these briefly because it is good and interesting things. I'll say that because I'm here in the van, all of the systems that are important, that have any form of important data, every one of them are encrypted. Somebody steals in, breaks in the van, steals computers. The only computers I have that are not are like the streaming computer here that I do the work on. Like pretty much everything on this computer eventually goes, onto the internet anyway. There's not a lot of secrets. I don't have emails. I'm not logged in any other accounts. There's really nothing on this computer. Although the next time I build this, I will probably encrypt it. And by the time I was building it last, I just didn't bother. All the other computers around here are utilizing the basic LUKS encryption we're talking about here. So in the encryption setup, when setting up a full disk encryption, which is definitely better than a home directory encryption, but a full disk encryption using LUKS, you'll be asked to provide a passphrase or a key. This one should be big and complicated. There are ways to tie this to a YubiKey. There are ways to tie this to other forms of authentication. So you do not have to absolutely do the passkey. There are other ways of doing it. One of those being cram this stuff into the TPM module. Why not? The LUKS header creation is the next part. The password you enter is not used directly as the encryption key. It goes through a derivation process, generates a more secure encryption key, which is then used to encrypt the master encryption key. Then that key is stored at the header of the beginning of the encrypted device. So one of the things you can do is when you create your encrypted drive, it is possible to extract that header. And so as long as you have that header and the passphrase, you can rewrite that header onto the disk and re-unlock the disk encryption. All right. So the passphrase prompt at boot, when you boot the system, it will prompt you for a passphrase that you initially provided. That is used to decrypt the LUKS header and basically unlock the device. And then we have the mapper integration. This is going to map the entire disk onto a virtual block, which then is utilized for the boot sectors. If you've tried to fix, like I did the video about fixing the Linux Mint system after the Linux Mint system borked itself on an update because the kernel direct, like the partition of the kernel modules got filled up, and I had to get in there and clean that up. But that was a fully encrypted system. And so I had to utilize this device mapper stuff to figure out how to get that system back. You can refer to that video about how to do that. Decryption and data access is the next one. So this is once it's decrypted, now it's basically available to be used like another system after it's mapped. And then allows for various encryption algorithms and various methodologies. You can have a more or less complicated system. So that's kind of how it works. Now, as far as utilizing this new TPM-backed methodology, this requires a verified boot. This requires your secure boot system, because the secure boot is going to check for signing of all of the components. Now, this is good, and again, this is bad. You're going to get a little bit more security, but it's going to come at a cost of some portability and some flexibility in your system. Really, the reason you'd want to do that is if your system is in a higher risk of being locally stolen. So in your house system, unless you're getting some high advanced robber, I mean, you think about the parallel, the intelligent people probably aren't burglarizing houses. The burglars probably aren't the intelligent people. So even if a burglar steals your computer, unless he's selling it to some computer genius, you wouldn't have a ton to worry about if you go with a better, a more flexible security model, we'll say. But if you have a case like a laptop, particularly a laptop with a lot of personal data on it, it does make sense to lock things down a whole lot more in this methodology, because locking it down in this more methodology gives you a little bit more than if you accidentally leave your computer, if you get up and pick up your coffee and someone runs with your computer out the door and has it, they're going to have a whole lot harder time getting in if you're following these steps. So the question is this a computer that has a higher risk of being taken in person, being accessed in person, or not? And that really is what it deals with. So the verified boot system, the secure boot process, it's going to boot everything up through the EFI firmware. And then this is going to check for signing keys on each of the various components of the boot process. And then this is where it starts calling the trusted platform modules. So the trusted platform module is a place to store these keys for anything that is encrypted or secrets. These are where they're trying to get you to do away with passwords because they're so inconvenient. You just sign in one time and you basically save all of your passwords to your TPM. The problem is hardware breaks, hardware gets lost, hardware gets stolen, and the easier you make it for people to not remember or store or think about their passwords, the greater risk they have of forgetting their passwords when their device finally croaks. And that raises a problem. This is why I'm not interested in all the passwordless stuff Apple's doing. They're using the same model. I'm not interested in the passwordless stuff that Windows is doing. They're using the same model. And I'm not really going to be interested in doing this on Linux because, again, it's using the same model. And if I have a system that goes bad, I want to be able to plop the disk out. Understand this. If this streaming computer right now that I'm doing on this dies, I can pop that disk out. I can put it onto an external disk reader, drop it in any other computer I have laying around, push the power button, boot by that hard drive, and I am on the exact operating system. If I have my disk encrypted by TPM, I ain't doing that. And then you're going to lose however long productivity it takes to get that back. And then it's going to be like your broken down car. Your head's in a funk until you can get it all back. So I'm not a huge fan of this. Now, as I said at the beginning, there are ways to set a recovery key that if you do need to take that disk off and access that disk on another machine, you can go through a more complicated process to get that back. The problem is this is designed to make everything easy, and the easy thing to do is to let the system do the work. And that really is the problem. So is this a function of laziness or something else? I think it's kind of a mix of both. I'm not interested in a TPM protecting my system because I want to maintain the deeper portability. And frankly, Lux encryption is good enough. All right. It is still very difficult to breach. You would have to get into that Lux encryption in the current standard, assuming you have a good passkey on it. It is going to take a supercomputer. Okay, so I think that this is overkill all for the sake of making it easier on people, not harder. Now, all these things I thought I would come across to here in a moment, but actually no, it's coming up down here in a minute. And then the measured boot, this involves looking at the cryptographic methods to make sure everything is still secure throughout. All right, so here is where a few places this can make sense. So for those looking at this solution, this does make sense. TPM-backed FDE brings in a number of improvements because it eliminates the need for users to manually enter passwords at boot. This is the important part. It provides a lower barrier of enabling encryption on shared enterprise environments. That I can 100% get behind, and it is a very good reason to do this. You have a single computer accessed by multiple different people in an enterprise environment. It makes sense for the system to get that, because if somebody wants to go in there and steal something, chances are they might be going there and just try and steal the hard drive, because it's easier to get out of the building with a hard drive than with a computer under your arm. Well, they get that hard drive back. If it's TPM locked, they're out of luck. That's really the thing. But barring your computer being used in a multiple deployment system in an enterprise environment, I don't really see a specific reason, because a lot of this is just eliminate your passphrase. Okay, so you'll forget your passphrase. I get this. That's kind of problematic. I'd rather my computer, every time I boot this computer up in the morning, it asks me for a passphrase, not the streaming one. It's not encrypted, but my main media PC. My chance of forgetting that password is 0. I use it multiple times a day. All right. The users who want a password in addition will still be able to increase their security posture. So this is good if you have super high-risk data, TPM plus an extra passphrase. That is going to be really good. But just for the average user, this is overkill. And we don't want to normalize this, because the negative consequences have deeper implications than tying all of this stuff to a single module on your system, particularly in a world where people routinely do not back up their data enough and do not understand the need to back up passkeys. Like, I don't need to back up keys for this. It's all managed by the computer, until you boot it up and you realize your computer's not working. I'm kind of dealing with that right now with one of my Raspberry Pis right now. For whatever reason, is not pushing power through the HDMI port. If I run it through an HDMI port that has external power, it works. But if I just run it regularly on the cable, it doesn't work. And I have tried going in and changing all the HDMI power settings. That doesn't have any impact on the system. So that's very interesting just to see how that's working. But now they get into protecting the key with the TPM. This just deals with looking at the various calculations being done within the secure boot. And then here's the authorization policy. These keys are only available if all of these calculations are coming in correct. So if there's a bite off somewhere, the thing will, what? I don't know. Something's gone goofy. And then, of course, we get down into the Ubuntu-specific implementation. And this is the role of snapd. TPM-backed FDE on classic Ubuntu desktop systems is based on the same architecture as Ubuntu Core, shares a number of design and implementation principles with it. So the bootloader, shim, and grub, and the kernel assets are delivered as snap packages via the gadget and kernel snaps, as opposed to delivering the Debian packages. As such, the snap agent is responsible for managing the full disk encryption throughout the lifecycle. The bootloader logic includes boot mode selection and kernel selection, and is encoded in the grub configuration, which is provided by snapd. All right. So in the installer, you pick which one you want. You can still go with the old methodology. This is an entirely Deb-based system, but it does have the same layout. So if you want to upgrade, there will be a potential upgrade path in the future. But they are, it wouldn't surprise me if pretty soon we start seeing this as the default option and the old way as the backup option, because that's what Ubuntu has been doing with snaps lately. So try TPM-backed full disk encryption today. You can test it out, of course, This is probably on the beta. Again, I've not looked at the beta yet, but I'll have a look at it sometime soon. So there we have it. Ubuntu is utilizing snaps to implement TPM-based full disk encryption. And I just can't think of anything that terrifies me a little bit more than Ubuntu doing that. Sounds kind of terrifying to me. But anyway, let me know your thoughts about this. Do you use TPM encryption? Have you been burned by TPM encryption before? Let me know all that stuff in the comments down below. Thanks for watching, and I hope that you enjoy switching to Linux. Thank you for watching this video from Switched to Linux. This channel would not be possible without the backing of the program supporters scrolling on the screen now. You can be a supporter at Patreon at patreon.com/TOMM or at thinklifemedia.com. I also want to thank the open source community who creates such excellent software that makes producing this show possible. Please remember to support your software communities. Thank you, and I hope that you enjoy switching to Linux.